Cool. Okay, so hi everyone. This is the JavaScript 3 lecture where we will be talking about scope functions and also asynchronous functions. So it's going to be pretty informative. It's going to be pretty dense. And so yeah, let's get into it. First of all, functions. There are actually two kinds of functions in JavaScript, and we have already introduced the first one, which is a regular function. And the regular function, you can write the regular function using the function keyword followed by the function name, which is pretty standard. You have something very similar in Python as well. And so this is a regular function. A regular function, if you remember, has this keyword and also has arguments binding. We will also be go more into detail about this and arguments binding later. But what this is essentially it's a keyword that refers to the object that the function is creating. And the arguments keyword is, if you like, we can just copy and paste it. Let's try this out. So if we have function, actually, if we console.log arguments, yeah, and if we call editor 1, 2, as you can see, besides giving us 3, it also prints out an argument variable. So yeah, arguments and this keyword are kind of like the two inherent thing for this regular JavaScript function. So what's the arrow function? Arrow function is very similar to a lambda function in Python, and it's just a way for you to make the code simpler and also more elegant. So if you see the code here, so this line of code is the same as this normal function up here. As you can tell, it's like a one-liner, which is pretty neat. Usually, if you're using a regular JavaScript function, you need to write at least 3 lines. First is a header, third is a closing tag, and the middle is the actual content. But for arrow function, you can condense everything into like 1 line. And how an arrow function, so first of all, why we call it an arrow function? Because there's like an arrow here, which is kind of like the keyword for arrow function. And so how arrow function is structured, is structured like this. So first of all, we define its name. This is how we define a variable. It's the same. Why do we use constant? Because usually a function will not really change during the course of a program. So we will usually use constant for any arrow function. And the way for arrow function to take in parameters is through this. It's just through a bracket, and it takes in x and y. And then this will be like the return statement afterwards. As you can see, this is kind of like a shorthand version of the arrow function. And this is a more complete version. This is a more complete version of an arrow function. So arrow function can also include like a curly bracket, and also like the return statement. Essentially, the difference between this and this is that if there's no like side effects, you can simply, if you just want to return something, for instance, you can omit this return and also omit the curly bracket and simply write the thing that you want to return after the arrow. And this way, it can also like return the thing that you want. So for instance, let's try this out. So it counts adder, let's call it adder arrow, A and B, A plus B. We need this. If we call adder arrow 1, 2, as you can see, it prints out 3. And you can also use to trigger some side effects if you want. For instance, you can use to print out. Yeah. Change the name, probably arrow 1, adder arrow 1, 1, 2. As you can see, it prints out the console.log 1 to instead of like doing those 3. So yeah, these are like how arrow function can be used. So this is an arrow function. And one pretty interesting thing about arrow function is that it does not have its own this argument or new keyword, which means that you cannot actually create a object using arrow function. We'll be going into this much more in detail like later on. So yeah. So this is arrow function. Do we have any questions up till this point? Cool. Okay. Then let's actually now let's talk about scope. Scope is very tricky in JavaScript, and usually like for instance, Python doesn't really have like block scope, and block scope is what kind of like makes JavaScript scope interesting. So there are 4 types of scope in JavaScript. There's a global scope, which is kind of like if you define a variable just in the file, then it will be in global scope. And there's also a local scope. Sometimes it's also called like function scope. But local scope is what essentially, if you define a variable inside a function, then this variable will be inside a local scope. And if you have like another function, it will be like in another local scope. So local scopes are like not connected with each other. There's also block scope. So block scope is anything that's within a curly bracket. For instance, a if statement, the things within an if statement will be in block scope. And there's also a lexicoscope that we will be talking about later. So let's take a look. So first of all, global scope. As we just talked about, any variables or function defined outside of a function becomes global scope. So here, the car name is in global scope. My function is also in global scope. However, my name is in local scope. So what's local scope? Any variables and function defined inside a function will become variables inside local scope. And you cannot access a local scope variable within global scope. However, you can access a global scope variable through a local scope. So let's try this out. So say we have a 20, and if we want to write a function that change a to say like 200. Oops, I've written too many Python these days. 200. And if we call change, wait, why a change? That's pretty weird. Oh yeah, wait, hang on a second. Oh yeah, sorry about that. So essentially, the idea is that you can access a global scope variable through local scope. However, you cannot access local scope variable within global scope. Yeah, so I was doing kind of like the reversing. Let me do that again. So let's say we have a function change, and inside this function, oops. Inside this function, we have like a equals to 20. And if we try to access a, as you can see, it will say a is not defined. And this is why we say that you cannot access a local scope variable within global scope. However, you can do the reverse, which I was just like demonstrating, I guess. So for instance, if a is 20, then you can have like a function change. And if you try to make it a equals 200, and if you call change, as you can see, a becomes 200. You can also like, if you want to print A inside a function, you can do that as well. If you call change, as you can see, 200 is printing out screen. Yeah, so essentially, you cannot access a local scope variable with outside like the global scope. Outside this local scope, you cannot access a local scope variable within like a global scope. However, you can do the reverse. So what's block scope? So everything that's defined within a curly bracket is in block scope. And we usually refer to block scope in a if statement or else statement scenario. So let's look at this code. So if true, as you can see here, we define three variables differently. We have defined var, let, and const. They are in this if statement. If we try to print out name, as you can see, we can successfully print out the name. However, if we want to print out the likes, as you can see, we will have an error saying that likes is not defined. Similarly to skills. And this is the main difference between var, let, and const. So essentially, var is kind of like the OG way to define variable when JavaScript is just came out. And however, people found that if we only have like a var, if we have like a var name somewhere in a if statement, if we accidentally want to like, if we accidentally have like another variable that has a similar name called name, and we will accidentally change the things inside this if statement, and we don't want that. So as a result, it comes up with let and const. And this way it can kind of like keep everything within the if statement. So this is pretty similar to like a local scope, but it is within this like if statement, else statement. It's essentially to make sure that people will not like accidentally cross some abstraction barrier and then like accidentally rename or change some of the variables inside an if statement previously or afterwards. So yeah, and this is kind of like the main difference between var and let and const. So what's the difference between let and const? Let is very similar to the old var, where it's still type dynamic, which means you can change it from like integer to string to whatever. And constant, as the name suggests, you cannot change it once you have defined. So for instance, if you define const scales equals JavaScript and PHP, even if within this curly bracket, you cannot change the scales variable. So this is what const is special about. So if const b equals 20, if you want to change b equals to 1, you will say the assignment to constant variable. And so this is just a way for you to define any constants, which is pretty neat. And also, pretty interesting about constant let is that you cannot redefine constant let twice. So for instance, if you have let a equals 10, if you try to do that again somewhere, okay, I guess let you can do that, but you cannot do that for const because like this is simply like this is simply the nature of const. If we do that again, as you can see, even if we like gave the same value to b, it will actually say that identifier b has already been declared. So yeah. And now let's take a look. So yeah, we have talked about var size or global, local, and you can access it. Yeah, we have already sort of talked about it. And also, var can be redeclared and update won't get an error. So yeah, and this is kind of like why this is what we have just talked about. Also, they have block scope, blah, blah, blah. Yeah. And up till this point, are there any questions? Oh yeah. About let cannot be redeclared. I think this is pretty weird. We can search it. Let script redeclared. Because I remember it can not be redeclared. Let's see. Oh, so probably the redeclaration is only limited within the same function or block scope. So yeah, let me make sure that I've added that into a notion. So it's let cannot be redeclared in a function block scope. And we can actually try this out. So let's see, expect. So say if we have like a if statement, and let's define it twice. Yeah, as you can see, identifier A has already been declared, which means that you cannot do this way. And let's see how var will behave. Oh, let me change the name. Okay, let me just do that. As you can see, if you use var, it will not have the error. So that is just like a kind of like a better way to define variable, and this way you can cause some error during compile time, which is pretty neat. So yeah. Now let's move on to talk about Lexicoscope. So what's Lexicoscope? Lexicoscope, we sort of already mentioned Lexicoscope, but it's essentially the idea that a variable defined outside of a function can be accessible inside another function, but the opposite is not true. So you can think about this as like the previous example that we have shown, where you can access a global variable through a local scope. However, you cannot access the variable inside the local scope through a global scope. And this is true inside like nested function as well. So as you can see, we have like a string of nested function here. And so we have function grandfather, his name, and then function parent, and then function child, and then we have a likes. And likes here, this likes, you cannot access this likes through within the grandfather function. You can also not access the likes within the parent function. However, you can only access likes within the child function. And this way, JavaScript kind of like protects the likes variable from being accessed by parent and grandfather. This is just like a way for us to like ensure data integrity, which is pretty neat. We can, however, the opposite is not true. So as a result, which means that we can access name within the child function. We can also access name within the parent function. We can also access name within the grandfather function. So yeah, and this is how the lexicoscope works. Lexicoscope essentially refers to this idea. And yeah, this is lexicoscope. Now let's move on to this. So this is a very, very tricky keyword in JavaScript. This is usually used within an object, and it is used to refer to the owner of the method. So for instance, let's see an example. Cool. Okay, let's do this. So say we want to create an object called people. And then people will have a name called Alex, age, and then a method, hello. And the method will be a function. And the function will print out console.log this.name. That's something else. I am. And if we call people.hello. Oops, let me add a, okay, yeah. Sorry for missing a space there. But if we call people.hello, as you can see, we will print out I am, and then this.name will refer to name Alex. And this is the this keyword. Essentially, the this keyword will refer if it's within a method, then the this keyword will refer to the people object. And since the people.name is Alex, you can check this out as well. People.name, it's Alex. And then this .name will have the value of like people.name. As a result, hello will print out I am Alex. And this, so why do I mention this is pretty tricky? Because like this has multiple different meanings within different contexts. So for instance, so I've just shown like this in a method. However, if you use this alone, as you can see, it refers to the window object. And window object has some pretty cool properties. For instance, this document is a property that we all really like to use. It refers to, as you can see, as I tap out this document, the web page, like all of the web page is actually being selected right now. This is because this document actually refers to like the entire document page. And usually you can also do document as well. So this is kind of like the global, kind of like the root of all variable. So that's using this alone. And using this in arrow function is kind of like the trickiest thing. So if you remember, I've just mentioned that there's no this keyword inside an arrow function. However, this doesn't mean that we cannot use this in an arrow function. So let's look at this example. So as you can see here, first of all, we define the age to be 10. And then here inside this function, person function, we define this age equals 42. And then we have a set timeout function call. What set timeout does is that it will run the function within the first parameter. It will run the function, it will run the first parameter after a certain time. In our case, it will be like after 1,000 milliseconds, which is after 1 second. So let's try to call person. As you can see, if we call person, it will actually print out this age, which is like here, and then followed by 42. So why does it print out 42? Isn't the arrow function like, doesn't the arrow function do not have a this keyword? So the answer is actually the arrow function that does not have a this keyword. However, if you use as this keyword inside a arrow function, it will automatically look up from the previous environment. And the previous environment that this function is in is this person function. And as a result, you will look at this.h, and then you will look at this.h equals 42, and as a result, it will print out 42. And that's how this keyword works in arrow function. And yeah, so this is like slightly different from the usual function. And if you can see, if we try to, so this is like using a normal function. As you can see, we print out this.i. However, if we are trying to use an arrow function, so let's make an arrow function. If we're trying to use an arrow function within an object, as you can see, it will print out undefined. And this is why I mentioned like arrow function does not have this keyword, because all of this keyword is actually inherent from its parent environment. And if we look at this method, this method is actually within the object itself. However, it's kind of like treated as in the same level as this object. As a result, the lexicoscope, the parent scope for this method, will be the global scope, and this keyword here will actually refer to the global scope. So as a result here, it prints out like the window object, which is the same if we print out this keyword inside the global scope as well. So that's why I mentioned that arrow function does not have this keyword. So the main takeaway, I guess, is that if you are using a method within an object, then please do not use arrow function. Please use the normal function if you want to have this binding. And if you use the arrow function, this binding will not work. So yeah. I know this will be a lot to take in, but any questions so far? Cool. And now let's move on to the next topic of the day, which is asynchronous JavaScript. So first of all, what is asynchronous? To understand asynchronous, we first need to understand what's the synchronous programming model. So in a synchronous programming model, things happen one at a time. Python is a prime example of a synchronous programming model. Sorry. When you call a function that performs a long-running action, for instance, if you want to run a machine learning model, the function will return only when the action has finished. And this will like stops your program for the time the action takes, which means that if the machine learning model training is going to take you like a day, you have to like stop for 1 day and then to wait for the thing to finish. An asynchronous model, on the other hand, allows multiple things to happen at the same time. And when you start an action, your program will continue to run. And when the action finishes, the program is informed and get access to the result. And this is how JavaScript works behind the scene. So here's a graph that kind of like displays how asynchronous work. So this is a single thread of control. So what's a thread? Thread is essentially, you can think of thread as one program, one core. And then this is how a synchronous single thread of control work. This blue line here represents a program. And here, as you can see, the first program finishes, and then the second program finishes, and then the third program finishes. And if we have two threads of control, then we can run two activities at the same time, which means that we can run this two at the same time. However, they are still synchronous. Since the reason for us to run multiple things at once is because we have two threads. However, if it's an asynchronous model, it will be very different. So after we run the first event, and while we wait for like it to be completed, we can also start to run the second event. So as you can see, after we run the first event, we need to wait for this amount of time. And while we are waiting, we directly start like the second event. And while the first event is running, the second event is also running. And when the first event is finished, the CPU will inform JavaScript, and then JavaScript will output the result. And here, after the second event finish, then the JavaScript will also output the result. As you can see, the first event and the second event is like running simultaneously. So this is an asynchronous model. And why do JavaScript use an asynchronous model? Because this is really important for JavaScript. Since we will be doing asynchronous action a lot, for instance, if a browser is trying to fetch data from a server, if it's like a shopping website, then we kind of want to like refresh. We want to render the browser while we are fetching the data. We don't want like the browser to wait for the data to be fetched and then we start rendering. This is not good. We want to like start everything at the same time. And that's why JavaScript is built upon a asynchronous action model. So yeah. And one key idea for asynchronous programming is the callback. So what's a callback? Callback, we have just demonstrated a callback function actually in our setTimeout example previously. So setTimeout is a function that takes in, first of all, a function, another function. And the second parameter will be a number of milliseconds. And it will essentially wait for 500 milliseconds before we run this command. So let's try this out. Let's make it like probably 22 seconds. So if we run this, as you can see, you wait for 2 seconds and then the tick comes up. We can make it like 5 seconds. And boom, as you can see, tick happens like after 5 seconds. And this is an example of a callback function. So how the setTimeout, so this is kind of like how we would usually write the setTimeout like signature. Essentially, this is saying that setTimeout will first of all take a callback function. Callback function is what usually we will do after a function is being performed. So for instance, here are some pseudocode. So say if we have 3 functions, a fetch data function, a process data function, and a load data function. The fetch data function has a signature of this. So let's try this out. Oops. So fetch data, it takes in a username and then a callback function. And then process data, it takes in some data and then takes in a callback function. And also load data, takes in data and then a callback function. This callback function are optional, of course. So what will the fetch data do is that after fetch data run some. So this is what a fetch data function will look like. So under the hood, you are like doing some fetch, like according to a username. And after it has finished fetch, you will call the callback here. And this is how fetch data works on underneath, under the hood. So, and this is how usually a JavaScript function will be structured. And this way we can like chain multiple function together. And this way, like after we call fetch data, and after we get the result, then we can call the process data. And usually a callback function can take in, as you can see here, a callback function takes in a response, and then the response is being put inside the process data. And this response is actually the return value of the fetch data. And this is how a callback function will work. So essentially, after the data is being fetched, it becomes a response, and then it's passing into the process data. And then after it processes, the process data is going to pass to the load data, and so on. So probably a more precise version will be something like this. So yeah, and these are all pseudocode. So this is a callback function. It's essentially a way for us to chain multiple functions that takes some time together. Do we have any questions for callback functions? We can actually look at a quick example. So let's code up something. So set timeout. So first of all, let's actually define a function. So this function will be called like function 2, I guess. Let's just call it like 2. And 2 will take in data callback. And then you want to run a set timeout under the hood. And then you will call callback. It will take in like, let's say it will take in like data. And then call callback data. And then with 2000 delay. Oops. Function. Okay. And let's see if we like call 2 with the data of like Alex console.log. And since callback function will usually takes in a parameter, let's do that. Data. Oops. Oh yeah, I forgot to. Hang on a second. Data callback. Yeah. So I defined this function kind of wrong. Let me redefine it. So actually here, we will just be running callback data. Cool. And then if we do this again, wait, what? Yeah, this is pretty weird. Oh, it's actually printing out stuff. Yeah, let's double check. Yeah. So essentially, what this is trying to do is that after we call to, we pass in the data, which is Alex, and then a callback function. And then this to function will takes in a will call set timeout with this callback function. And as a result, we print out to, or we print out Alex, which is the data we just pass in. So this is kind of like a pretty primitive example of how we might use a callback. So cool. And so that's for the callback. So callbacks are great. However, when the callback chains get too long, it will be very hard to maintain. For instance, here, we can see that this is only like 3 functions chained together. And if we have like, say, if we have like 5 functions that we need to perform, you'll be like load data, and then like another function, and then within this function, we'll have another function. As you can see, it will be like pretty annoying. As a result, we have something called promises. Promise is an object that produces a single value sometime in the future. So, and it will either be a resolved value or a reason that it's not resolved, which in other words, an error. And promise may be in 3 possible states. The first of all is fulfilled, secondly is rejected, and third of all is pending. This kind of like correspond to the callback function, where callback function usually will also passing, so besides callback, will also passing a error parameter. So yes, usually we'll have like fetch data, some like parameters, callback function, and then an error. And what this does is that the fetch data function will call callback when it's like run successfully with this parameter, and it will call error if it's run like not successfully or it has like encountered some error. How do you know how much time you need to pause? Essentially, yeah, so there's a question in chat asking, how do you know how much time you need to pause? So usually, so this is why we use the callback function. The callback function, we can kind of like ignore how much time that we need to like stop. So for instance, if fetch here takes us some time, then we can simply, given the kind of like the structure of this function, you will naturally call the callback function once the fetch function is finished. The reason for us to use like setML in our example is that setML is just a pretty good demonstration of how a callback function can be used. Usually in real world, we can just structure the function like this, and then it will be called like automatically after the fetch function is finished running. So yeah. And then yeah, so this is how a callback function will usually be structured. And so this corresponds to the promises status as well. So first of all, if it's fulfilled, then we'll call the callback function. If it's like rejected, then we will call the error function. And if it's pending, it means that we haven't get the result yet. So let's see some real example of how we can use a promise. So first of all, let's define a promise. And just like I've said, when we use setML, it's essentially like pretty good choice for us to like play around with like delayed function. So so first of all, let's define a function called wait. And wait is an arrow function. It takes in time as a parameter. and it returns a new promise. So this whole thing is a new promise. So a promise, it takes in a function, and this function, well, usually it's not like a function that can be done in like synchronously. It cannot be done like immediately. It's oftentimes some functions that take some time to perform. And here, to mimic this environment, we have used a setTimeout function again. So now let's create a function. Let's now create a promise. So let's just call it RP equals weight 3000. And if you look at RP, if you just type it out in the terminal, as you can see, this is like a promise. And there's also a promise status into it. It says it's fulfilled because 3 seconds is just pretty short. As a result, it's already fulfilled. And so how do we use a promise once it's fulfilled? We can do this. So simply by using rp.then. So .then method is saying that if the promise is fulfilled, then please run this code inside the .then function. So we can then proceed to run another function, for instance, console.log hello. Hello. And as you can see, we print out hello. This might not be the best thing to demonstrate inside a console, since like console kind of like do things separately. So let's try to write everything inside one cell. So new promise. Oh wait. Nice. And let's create a promise. Let's just call it PR. Weight 3000. We can actually try to print out the PR here. And then after the PR is resolved, let's console.log hello. And also let's console.log the PR. And if we hit enter, as you can see, we have actually 3 results. So here, the first result is saying that, let's see. Oh, okay. Okay, yeah. So first of all, as you can see here, the first result, the first console.log is from this console.log. It's saying that after we create this new promise, and if we just directly call console.log, as you can see, it's now still pending because we're still waiting for the 3 seconds when it's like being processed. And you can like change this setTimeout function to, for instance, a function that's fetching data. It will be the same. And afterwards, we also have like a promise as pending. Why do we have this? Is because since we're actually when it says evaluating this parameter, it will actually print out the PR again, which is pretty annoying. But however, this is just how the compiler will work. And as you can see, after 3 seconds, it print out hello PR again. As you can see, since we call this function after the setTimeout, like as you can see, the resolve parameter here is actually pointing to this function. And we call the resolve function, which is this console.log after 3 seconds. It means that after 3 seconds, our PR will be already resolved. As you can see here, it's also showing here in the promise status, which is saying that it's already fulfilled. The reason for us to see that the promise state fulfilled, the promise state fulfilled here is because that the promise state will always refer to the current state of the promise, which is already fulfilled. The state that's like for the promise that's like happened beforehand will be showing here, which is pending. So yeah. And using promise is kind of like a standard way of how we will deal with asynchronous function, aka any functions that need some time to process from now on. Let's look at a real life example. And I think a real life example will be much clearer than using like setup functions. So let's see. So let's introduce fetch actually. So fetch is a API that allows us to fetch data from another API. And this is super useful. Essentially, like this is the most useful API. Fetch API is the most useful API for front, I would say. And also fetch API is asynchronous. And since it allows us to fetch data from another API, and this is a great practice for us to like, learn more about asynchronous code. And we will be using the NASA Open API project. So this is pretty cool. Essentially, you can fetch some pretty cool planets. We'll be using this astronomy picture of the day. As you can see, you can fetch some pretty cool images from NASA. And the best thing about this is completely free. So let's do this. So let's copy and paste it. So what this does is that it will send a GET request to this URL. And if we just visit the URL, we can actually see the result. Let's actually visit it first before we call the fetch API. As you can see, if we visit, in your page, it will probably look something like this. I have a plugin to make this nicely formatted. We will get a JSON response. A JSON response is how like a website is usually, how a website will usually transmit data. And as you can see, we get quite a lot of interesting data. For instance, a URL pointing to the image that's stored on the NASA server. And so, yeah. And so let's try to fetch all of this through our fetch API. And let's try to console.log the data. As you can see, after we call this, it will first of all fetch the data, all of this, into the as a result. And then if we call .then method, so essentially this fetch here will return a promise. So as you can see, if we just call this fetch, it will return a promise. Let's store it somewhere here. And if we call a.then, we can essentially access the result that's like from this fetch. So for instance, we can call response console.log response. And as you can see, we got a response object. And this response object is not that really interesting to see because it's in a response format. It's in HTML response format. And to convert this into a more readable way, we can do a.then response and then response.json. And this JSON parameter will make the response a readable format. And then we can concatenate a .then format because like .then function, because JSON format actually is an asynchronous function as well. So as a result, we can then print out console.log data. As you can see, we got a nicely formatted JSON data showing up here, which is the same here. So yeah, so that's for the fetch API and also the how do we use promises. Are there any questions? Okay, cool. If there isn't any question, and feel free to raise the question if you think about it afterwards. Because right now we will be talking about backend versus front end, and this will be a pretty interesting talk because like y'all will be doing the selection form by the end of this week. So yeah. So first of all, what's front end and what's backend? We kind of already mentioned this in the general meeting as well as our club info session. But front end is essentially everything that you see on a website: the page layout, the navigation bar, and the buttons. And people might think that front end can be a little bit easier than back end, and that's simply not true because UI can be super complicated. If you, for instance, look at Amazon, the UI for Amazon is like pretty complicated. As you can see, like there are plenty of boxes here, and all of this needs to be dynamically loaded. And it's pretty hard to like generate all of this data and handle all of this business logic. As a result, front end, it can be pretty complicated, and it will be much more than a static page. And you might also need to dynamically load and also cache data, and also handle some in-browser database, which is called cookies. And we will be covering all of this interesting stuff in our front end branch. And also with the development of front end framework, namely React and Vue and Angular, more and more data processing and logic are now started to place inside the front end as well. So it's a very exciting era for front end developers. It's at least definitely much better than the dark time where we can just use HTML and CSS to code up a website. So yeah. And backend is definitely also very exciting as well. If you choose a backend, so first of all, what's a backend? Backend consists usually of three main components. First of all, it's a server. Server is where all the data is sent to and being processed. So for instance, we have just used the NASA API database, a NASA API server. And when we are like using the fetch and followed by a URL, we are actually visiting a server. And it is the server that sends us all this information. And database is where all the data is stored. So for instance, NASA will have a database that store all this information. And then the server is like in charge of sending all the information from the database to the website or to a fetch API and stuff like that. So what's a cloud? Cloud is where you can deploy the database and the server. So before cloud becomes a thing, people usually will buy buy their own database, buy their own server, set it up using like a computer, using some old computers. However, nowadays we usually just simply rent a server on AWS, and then we can simply deploy the server and also the database onto a cloud server farm. And this proves to be a much better way for us to set up a server and a database. And cloud is where you can do that. And we'll be covering cloud as well. So this is kind of like the content for front and backend. So tech stack that we will be covering for front, it will be mainly on React, because React is a pretty big topic. Like to be honest, if you can do React, you can interview for most of the front end developer position as an intern. Yeah. Also, we'll be covering Figma, which is a very exciting design tool that people are used today. So for Backhand Stack, we'll be covering server, database, and cloud. So for server, we have essentially two choices. First of all, it's Node.js. Node.js is a framework based on JavaScript. We'll also be talking about Django. Django is a framework based on Python. Both of these are very robust. They're used by huge companies. We'll also be talking about MongoDB and PostgreSQL. These two are also super robust. They're also used by like super large companies. There are kind of like two different types of databases. MongoDB this is called a NoSQL database. What NoSQL databases does is it's like different from the traditional database that you will be learning. For instance, courses like CS186. PostgreSQL is a traditional database. It's a SQL database. It's a database that you will be learning in CS186 actually. So yeah, we'll be also covering cloud. And we'll be using AWS. We'll also be using Heroku from time to time before we talk about AWS. So yeah. Do y'all have any questions for me for the front and back end, or any information that you want to know for you to, help you select a front and back end track?
If we do choose one track, but we are still like interested in like learning, kind of just going to lectures for the other one as well, is that possible?
That's probably, so if you want to go to the lecture synchronously, that's not probably possible because like the backend lecture and front lecture unfortunately happen at the same time. However, they're still like recording to watch. And also if you take a look at the front and backend track, we actually would teach some backend during front lecture as well, during front track as well. So there will be 3 backend primers, and each will be covering like a topic. So for instance, backend primer 1 will be talking about server, will be covering 2 will be covering database, 3 will be covering cloud. So even if you choose front and not attending any backend database, you can still get this holistic full stack experience. So yeah.
Got it. Thank you.
Mm-hmm. Any other questions? Yeah, remember to please fill out the form by the end of this week. And we cannot guarantee that you get get your preference for your track, because we are trying to balance out the number of people in front track and back end track. And historically, we have more people prefer back-end track, but I want to say that personally, I really like front-end track. Actually, all our teachers really like front-end track as well. So front-end track is definitely a very interesting track to learn as well. So yeah, it's definitely more than just boring CSS and positioning. I promise you that. So yeah, but if you're interested in back-end track, definitely go for it. This is why we include a skill. And so yeah, we'll definitely try our best to fit everyone's need. So yeah.
When will we find out which track we're on?
I think you can probably find out about that. So yeah, at the end of I would say before next Monday lecture. So yeah.
Okay.
Mm-hmm. Actually, let me.
Sorry. Sorry. I was gonna ask do we have lecture like during spring break too?
Oh, we won't have lecture during spring break.
Okay.
Yeah, actually, let me make it let me make the deadline a little bit earlier. Oh, it's already March 20th. Nice. If that's the case, I think y'all can know your choice by Sunday. So yeah, it's worried. Do we have any other questions? Cool. If that's the case.